Okay, first off, sorry about the last video, the 1.3 continuity. Sorry it took 2 videos. There's just a lot of information, so it was one of the longer ones. Now, 1.3 with end behaviors, this should be a shorter one. It's really an easy concept. You just can't really think about it. All right, so use limits to describe end behaviors of functions. So remember, we're looking as limits is looking at graphs and functions as they approach certain things, certain numbers and stuff. So now, of course, end behaviors is going to be the ends of the graph. So the end behavior of a function describes how a function behaves at either end of the graph. That is, end behavior is what happens to the value of f of x as x increases or decreases with the bound, and becoming greater and greater or and more negative to describe the end behavior of a graph. You can use the concept of a limit. So I'm going to try to make this a little bit more simple. But what it is as I approach the left of the domain, or negative infinity, because if I kept going this way on the domain going to the left, that's approaching negative infinity. So as x approaches negative infinity, the limit of x approaches negative infinity of f of x, we don't even know what it is. We're just saying it's f of x. What's happening is, as I go left, the actual graph is going up. So the range is going up. So as the limit of f of x approaches negative infinity, as it approaches this way, the graph is going up, hence it's approaching infinity. So remember, this is going to be your domain, and this is going to be your range. So the end behavior is looking at the end of the graph, the edge of it. All right? Now, if we're approaching the right, we're going to positive infinity. So as the limit of f of x approaches infinity, we are going right, the domain is going to infinity. So we're looking at this graph, and this graph is going down on the right. So since it's going down on the right, the range is approaching negative infinity. So as the limit of f of x approaches infinity, it equals negative infinity. So we're just looking at the ends of it. Now, it's not always going to go infinity and negative infinity, and I do have an example for that here in a little bit. Okay, so we're going to look at this one. So we're going to look at it as the limit as x approaches negative infinity of f of x, and f of x is x to the third, negative x to the third over 4 plus 3x squared over 4 minus x over 2. We're going to look at that. Nope. Negative infinity. And we're going to look at the limit as x approach infinity of f of x. So, remember, negative infinity is to the left. It's the domain. So we're looking left. So as I'm looking left, what's happening to the graph? Well, as I'm looking left, the graph's going up. So the graph's going to infinity. So as I approach negative infinity, the graph is going to infinity. Now, as the limit of f of x approaches infinity, so as I'm looking right, what's going on to the graph? So I'm looking, and as I'm looking to the right, the graph is going down. So I'm going to negative infinity. Well, what you can do though is that's just by looking at the graph. Now, we can support this numerically by using a table of numbers. So what we're going to do first is we're going to look at the negative infinity. And we're going to use 0 as our middle part. So I'm going to make my table of numbers. And I think the hardest part is just coming up with the numbers. But if I'm going this way and I'm going to the left forever as I approach negative infinity, pick really big numbers. So I'm going to pick negative 100, negative 1,000. You can go negative 10,000, negative 100,000. We're just picking really big numbers. So, and as I go right, I'm going this way on the side of the 0, and I'm going to infinity again. I'm just going to pick 100, and I'm going to pick 1,000. Now, I actually did the computation a little earlier, so that way it won't take that much more time on the video. So let me quickly find it fast. And I lost it. Okay, I found it. All right, so, and you know, let's pick bigger numbers. Let's pick this being 10,000, and let's pick this being 1,000. Those are the actual numbers I use. So 1,000 and 10,000. So it doesn't really matter. We're just trying to get really big numbers to prove a point. So if I plug 10,000 into this function, f of x, I'm going to get 2.5 times 10 to the 11th. Really, 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 really big number. And if I plug 1,000 in, I'm going to get 2.5 times 10 to the 8th. So another really, really big number. So obviously it's getting bigger and it's getting bigger, so hence I'm going to infinity. That's kind of the numerical proof. If I plug in 0, I get 0, obviously, because everything has x. Alright, so now if I plug in 1,000, I'm going to get negative 2.5 times 10. And I know it's going to be hard to read, I didn't leave much space, to the 8. And if I plug in 10,000, I'll put down here, negative 2.5 times 10 to the 11th. Okay? So it's just me plugging those numbers into the equation, because everyone always asks, where do you get those numbers from? Obviously, I'm getting smaller. Even though the numbers look bigger, it's a negative. I'm getting smaller, so it's going to negative infinity. So that's proving it numerically. So in behaviors, again, if I'm going to negative infinity, which is my domain, I'm looking left and I'm looking at what's going on with the graph. So the graph's going up, it's infinity. If it was going down, it'd be negative infinity. Okay, going to the right, I'm looking right, that's going to positive infinity. So I'm looking at right, the graph's going down, hence if that's going to be negative infinity. It takes a little bit to get used to, but it's really not that hard. Okay, now, what happens if it's actually approaching something? So, use the graph of the function to describe its ends. Support the conjecture numerically. So, we're going to look at this. Is it approaching this way and it's approaching this way? Well, if you really, really look at it, it actually has a horizontal asymptote. But we haven't proved that yet. So, what we're looking at as the limit of f of x, and f of x is 3x minus 2 over x plus 1. Of x approach negative infinity, and the limit of x approach infinity of f of x. So, what's happening is, let's look at negative infinity. I'm going to the left, and it's getting really close to this line I drew. We're going to estimate the line to be 3. So it's getting really, really, really close to this line, but it's actually never going to hit it. So as the limit of f of x approaches negative infinity, I'm getting really close to the number 3. Again, as I go right, I'm going right, it's getting really close, it's starting to get above, really, really close to that line. Never touching it, but I'm approaching 3. And because 3 is the y-axis. So that's just me looking at the graphs, me making my estimations. Now, if I want to make a table, and I did the table earlier to kind of help out. So, let's do the table. I'll try to do it this way, maybe you can read it better. Okay, I'm going to do that. Okay, I'm going to use 0 as my middle ground again, because 0 is just really easy as your middle ground. Then I'm going to do negative 1,000, negative 10,000, 1,000, and 10,000. Okay, I'm just picking numbers, because everybody wonder, where do those numbers come from? I'm just picking numbers. If I'm going that way, obviously I'm going to hit negative 10,000. If you want to put negative million in, go for it. It's just a really big number. So if I plug in 10,000, what I'm going to get is 3.0005. If I plug in 1,000, I get 3.005. If I plug in 0, I get negative 2. If I plug in 1,000, I get 2.995. And then if I plug in 10,000, 2.9995. So, as I approach negative infinity, it's getting really, really, really close to 3. And if I approach positive infinity, it's getting really, really, really close to 3. So, just looking at the graph, I'm approaching 3 on the limits. So, and that is it for this lesson. I tried to make this one a lot shorter. Please ask questions. In behaviors really kind of confuse people a lot. But you just got to remember, if you're looking for negative infinity for the domain, you're looking left. If you're looking at positive infinity, you're looking right. And then you're looking at what's going on with the graph up and down. Okay, so the homework for this was page 30, 22 through 29 all, and 34 through 40 even. So please ask questions if you need help.